Hi guys, welcome to part 11 of this series of videos on building a relational model for Dogen. Wow, part 11, eh? Time's flying. So, in the last video we tried to be very clever and build a script that was doing all sorts of cleverness in Git, checking things, reverting, and so on. And as we concluded, it was not exactly trivial to get the script working. The reason why is because of state. Every time you keep committing and reverting and merging and rebasing and all these things, you end up getting yourself into some rather unpredictable states. The state machine is just too complex. There's just too many permutations. You could do a pull and there's no commits. You could do a pull, there's some commits, maybe there's some kind of clash. It seemed, as a thought experiment, seemed like an easy thing to do, but as always with software engineering, best thing to do is to try to do it and see what breaks. And that session was quite a good demonstration that this is not a practical approach. So if we go back to our backlog, the alternative is to just go for the approach of not committing the state. So we had all these other approaches. But the simplest thing is, let's just not bother committing the state. We're just going to generate the code, build, run tests, trash it, next day of course, trash it all, and then do the same thing again. This is a very easy way to guarantee the state is good, because we always start from master, and then we just run code generation in master. That should give us a much simpler state machine. Of course we lose traceability in the sense that we can't see what things look like 3 days ago, 4 days ago. But the good side of it is we know exactly the commit of master that we were in, and that commit generates both the code generator and the generated code. So in theory, you got all you need to replicate the setup. You quite literally just need to check out that commit, build the code generator, and run the code generator with full generation on, and you should get back to exactly the same state. The other thing that we will lose as well is if I go to C dash, at present we seem to get some information here about oh, interestingly, don't seem to, well, perhaps it's because we didn't check anything in from one day to the next. Oh no, we don't seem to get anything on the Git update, so actually we're not actually losing anything in regards to that. I thought we actually saw the commits coming through from one night to the next, so we don't get that, so that's not a problem then. So okay, so that's what we're going to do. I've already, whilst you were away, I've already started rewriting the script in those terms. I also spotted or wrote a story for the problem we're having with the Windows builds. So the current state in terms of the builds is the nightlies are looking okay. Pretty much all the builds, with the exception of the CL, Clank CL on Windows release, are green for Dogen itself. And in terms of the reference model in C++, we are having problems at present with MSVC, and of course we have a lot of failures in tests. These failures need to be investigated, and we're not going to worry about those right now. What we're worried about is these, because these are new since we've changed generated tests. So since we created the facet generated tests, those appeared. So our job today will be first to sort the problem out with those two models, because that seems to be an easy thing to do. And secondly, we need to put this nightly build running the generated tests. We'll just run a couple of experimental builds for today, and then we'll commit the code for the nightly, so that tomorrow's nightly will attempt to run these generated tests on Dogen. So let's just get, in fact we should probably clock some time for producing videos. Not a lot though, to be honest, about 10 minutes maybe. Because I was checking out the video for yesterday, and as you can see we are reaching the threshold for end of sprint. Just to recap, now that I'm working part-time, we determine the sprint by reaching 80 hours. We should also update the mission statement for this sprint. This was very ambitious. We always have a sort of an initial mission statement in the sprint, and then halfway through the sprint we then conclude what the actual statement is, depending on the difficulties of the problems. So the mission statement for this sprint is incorporate the relational model, if you could spell, into Dogen. That'll be an achievement if we manage to do that, and we still have today and the weekend, so I mean, I'm not going to bother to just finish the sprint at exactly 80 hours. I will just finish the sprint on the end of the weekend, so that Monday we start a new sprint. Let's just quickly rename these models. So in order to rename a model in Dogen, and at the moment this is a fairly manual process, the good thing about it is because we are dealing with a reference model, and the reference model is fully generated. So the two models that are causing problems are two layers with objects, and do not delete empty folders. These names are too long for Windows apparently. Interestingly enough, they're not even the longest. I wonder why the other models are not causing problems. So what we'll do is actually, for a laugh, since we're here, let's just understand which ones are the biggest. Right, so clearly enable facets serialization should be a problem, because that's one of the biggest models we've got. So why did that not cause a problem? And then of course we see do not delete empty tiers, two layers with objects as the two next largest names. So we only seem to have two failures. Now that's very puzzling. Let's have a quick look at the tests. Perhaps the passing tests. What is the quickest way to know? Perhaps if we just go straight to the... Oh, in fact we have the build log. So I'll just hop over to the build log. And as you can see here, we seem to have built that project without a problem. It's rather puzzling. I wonder if that model somehow is not generating tests, perhaps. For some reason. No, indeed, that is actually the case. So as you can see here, we have a profile, enable semantic type serialization. And if I look at profiles, I bet you all of these facets only enable something very specific, not the tests. To be fair, these are quite trivial models anyway. We have these tests covered somewhere else, so we probably don't need tests for these. And it's the test that's causing the problem, so we shall just ignore that model then. And look at the two other big ones. Right, so as I was saying, to generate a model with a different name, given that these models are not particularly special. Okay, do not delete entities is probably a bit special. Presumably we've generated some entities somewhere. Not exactly in here, but somewhere we must have some directories. Interesting. Not quite clear what this model is testing, given there are no empty directories. Let's have a look at the comments in the model. Perhaps we broke this test, did not realize it. This model is designed to test that setting delete empty directories to false does not delete directories. Because Git does not version control empty directories, the model requires some additional setup in order to be tested. You need to generate this monitor folder, programmatically create some empty directories, and then check to see if they are deleted. A similar test for the flag set to true can be done in any test model. Interesting. Okay, so the idea originally was that we would programmatically create an empty directory, which makes me think that perhaps we do that, like perhaps in CMake. So the idea here should really be that we perhaps this is a test that we used to run when we had test model sanitizer, which was our old way of doing tests, which by the way reminds me we still have some remnants of test model sanitizer here. They must be deleted. Let's just quickly do that. Wrong git. Here. Some reason we don't seem to. Alright, so as I was saying, this test is probably rotted, and we just never noticed prior to this. Not quite sure what git. How my git determines where buffers go. Emacs seems a bit random. So, okay, what we want is to have a view of what Git's doing for C++ ref import. Right, so what we want to do then is to say remove, so test model, sanitizer, remove last remnants. Okay, so we need to remove the last element of sanitizer because we've deleted it in the past. Now, we're in a bit of a situation with regards to this test, because I think what happened was this test was originally part of the test model sanitizer, and within test model sanitizer we had some logic to create a folder. Actually no. When we moved from test model sanitizer, we put these tests in Dogen itself. Yes, this is now making a bit more sense. Sorry, let's not move away from the nightly here. So what we did all those months ago is, instead of running tests in the reference model itself, we run the tests from within Dogen, pointing to the reference model. So if I look at something like engine, perhaps, the manual tests, right, one of these guys here, it's always difficult to remember which one is which, but not this chap. One of these guys here, not this chap either, so it must be this guy. So hopefully we'll find a reference to the empty. Okay, here we are. So delete extra. Seems to me ignore extra for whatever random reason. We've not done a very good job of naming these tests, because the tests don't actually match the model name, which is always for me a very rather annoying thing. Perhaps because the names of these model names are so large. Exactly the problem we're having at present. Right, so what we'll do is, this all looks a bit confusing, but it's always good to check these things, because you don't really want to be running tests for no reason, and you don't want to have broken tests. So what we need to do here is we need to ensure that the model is being tested and is being tested correctly. So do not delete empty dirs. Here we are. So there is a delete empty dirs here, mapping to that. So now the question is, do we? No. Okay, so what seems to be happening at the moment is we don't seem to have a test for this model. The test for this model should be that it should create the folder, run the model, and ensure that the folder is still there. Now we're not going to get ourselves too lost with this, because otherwise, as usual, this is never ending. So what we'll do instead is first we look at backlog, because we might have noticed this problem before. Nope. Okay, so now we're going to raise the story. Create a test for not deleting empty directories. So at present we have created model to test that the delete, well actually to be very precise we probably should really call this by its name, so that the flag LSP seems to be kicking in. So we're trying to say that the flag, and then the flag is MASD.extraction, let's delete empty directories. So we should say that setting to false the flag, and we probably could just inline the flag here. Results in not deleting empty directories. We were probably testing this correctly during the test model sanitizer days, but in the move, but when moving the tests into Dogen, they seem to have lost this one. The test should create a folder inside the model, run code generation, and ensure the folder, create an empty folder really. So one or more empty folders inside the model. Run code generation, ensure the folders are still there afterwards. Presumably. Okay, cool. So now we captured this, so we're not going to lose this story. We're not going to worry about it right now. We will capture it and we will just keep everything exactly as it is. So the logic will be to just fix the problem at hand before we get completely sidetracked. So given that that test is not doing anything particularly clever, we can just delete the model altogether. And the second one was 2 layers with objects, and we know that 2 layers with objects also doesn't do anything clever. It just tests that you can create multiple layers in Dia. So for example, I'll just show you very quickly what this does. Dia supports multiple layers, and you can there's a dialogue somewhere, shows you all the layers. We never ever use layers, so it always requires a little bit of fiddling to figure out where things are. Fact witness is one of those tests. There used to be a dialogue somewhere. Why is it right click? No. Must say, although I've been using Dia for many years, I'm not much of a power user of Dia really. I used a very small number of features quite a lot, but I haven't really mastered the UI. I think. Right, see, as you can see here, this is the second layer. And there must be a way to select. The tools, there was a way, I quite remember one years ago, many years ago when we created this test, there was a way to choose which layer you're viewing. Show layers, this is the one. Okay, took our time but we got there in the end. Now we probably have too many things open, so not so easy to view. But as you can see here, they have two layers, backgrounds and the second layer here. And I think what's happening at the moment is... Yes, exactly. So you see, you have objects in different layers. And the objective of this test is just to see what happens if you got multiple layers. And nothing should happen really. One thing we should put also here on this particular... Sorry, let me just write this story down as well. So if you remember, sorry to be jumping all over the place, but one thing that is important is whenever you remember something, to write it down immediately before you forget. So if you remember, we created a fake type in the injection JSON model. Injection JSON model. And so let's just describe this. We added a fake. Oh, actually, before we do that, let's do such a fake. There we go. So we already have a story for it. Okay, so in fact, we need two stories really. The story you see below is the real story to solve the problem. However, we need a sort of a temporary fix because we don't really want fake types. I mean, this is crazy, right? So we added a fake type to the injection JSON model C, and then if you just do a Control C, Control C L, and Control L. There is a better solution to this. Just disable generated tests in this model for now. That's a better way of doing it really. We probably should just put a warning there so we don't forget to enable it once we add a type. But fake types are always very confusing. And so this is something we probably want to do as soon as we're done with this, because this is just ugly. We don't want to leave all this ugly stuff. I mean, there's levels of ugliness, even the test is slightly less ugly. How are we doing for time? Right now, so where were we? So what I was going to suggest is that we simply delete these two directories with all of their contents. Then we go to models, locate these two chaps, rename them to something slightly more sensible, such as skip empty verbs. Now we've done some calculations and we figured out that actually this is small enough. It should work. What happened here? Okay, one must be very careful when doing this sort of thing, because what Emacs does by default, which is somewhat surprising sometimes, if you've got two direct buffers open and you do a rename, it assumes, at least after the preload configuration, it assumes you're trying to move the file from one directory to another. And sometimes if you're actually trying to rename a file, it could be slightly surprising that you end up moving the file whilst renaming, because you don't tend to pay attention to what the path is. And that's what happened there. Luckily, by sheer luck, we had deleted... the other folder, so the move files. Otherwise it would have been rather problematic. Now what we need to do is, if you remember, in Dogen we don't just take the file name to name the model. I mean, we should probably default it if model modules is not supplied. I'm sure we have a story for that in the backlog, but we don't at the moment. So we must make sure that model name is updated as well, otherwise it will be for nothing. And of course we must remember to do this in both JSON and now you see, I'll show you what I meant a second ago. See, it's trying to move it to dia, which is the other folder over there. So we just have to make sure we don't get fooled by that. Skip empty dirs. And 2 layers. And again, for good measure, we must just make sure that we update the model name. And this job too. So we checked that the path was about right, and so that should work. Now, now what we need to do is we need to tell our list of models that the models have changed name. And here is the chap. Okay, cool. And then we should, in theory, just be able to ask Dogen to generate these models. Okay. And this is sort of a bootstrapping problem. We're simultaneously trying to include the model and generate the model. If you remember, we deleted the model, those 2 models, with the old names. So, for good measure, we must make sure we don't ask CMake do something silly and include. Now hopefully you should see skip here, and we should also see whatever the other name was. 2 layers, wasn't it? That looks good. Okay, so if I ask Git to tell me what's changed, a whole lot of interesting things start coming up. Okie dokie, and then last but not least, what happens if we try to build these new models? Nothing, as you'd expect. Obviously, this was a test to for the reader, and of course that's also what we'd expect, because when we commented out these chaps, we didn't update their names. That's all very predictable. Right, cool. So now we're in the actual world. Okay, this is also expected. So what's happened here is, for good measure, we should probably grep for these names, because of course we seem to be hitting a lot of cases where we just seem to be forgetting to update these. Oh, as it happens, we're down to the last one now. So we need to make sure we're pointing to the right directories and include files. 2 layers is this guy here. Okay, now then we expect compilation to succeed. Because we changed the includes, CMake rewards us with a massive build of everything in this project. So whilst that's going on, we can do some thinking. So this is hopefully the last thing stopping us from seeing green on Windows, green on Linux. Mostly, I mean, Klaus's tool will still complain that we have all those failures. But to be fair, we do want that to be the case, because we want to see here that these tests are failing. So this, whilst it's a bit annoying that we have these 40 failures and everything else is green, and this then results on every commit coming in. So if I look at commits, you'll see here that they all come in as X, purely because of interesting enough, we have 2 things failing here. This could be because originally we had some errors in the build, as you can see here. But at present, hopefully the build history should be... Oh, it isn't actually. Oh, okay. What is the problem now? Oh, okay, right. Sadly, this is just sometimes. It's really nothing we can do. OS X is a bit like that. Sometimes OS X just decides they had enough, stops stocking for a while, and our friends at Travis decide to kill the build. I'm afraid I'm coughing a bit. And there's really nothing we can do about that. I don't want to mark the OS X builds as exclude or ignore just because of that, because most of the time, as you can see in that one, it works. And it would be a bit silly to do that. It has to do with packaging, I believe. That time it wasn't, because we were still with 85, but most of the times that I've seen this in the past is just CPAC takes too long to generate the package. If you recall, we use CPAC to create binaries. I've mentioned this before in my release notes. So if you want to download Dogen builds, you can just jump over to BinTray, and in BinTray we have the Dogen builds here, and what we do is we normally do builds for the current sprint. So for example, at the moment we're in sprint 19, we have been there for a while because we're working part-time, but we also of course have builds for the previous sprint. And really, the build for the previous sprint is nothing but the last build that we did on that sprint. There's nothing special about it. It's just the version number changes and just the last build. So if you go up to this folder here, you can see that we have binaries for Windows, and in a much nicer way, we have binaries for OS X and binaries for Linux, all 64-bit. I haven't quite managed to figure out how to move the Windows binaries into this directory. Artifactory, AppWare doesn't seem to like that idea. So yes, what we're doing, we have finished our builds. We can now run the tests. Everything is green. And now what we'll do is we will jump over to Git, and we will say 2 layers, skip empty folders, rename models to make model name smaller. Windows builds are failing because Windows MSVC, should we say, because these two models have blown the maximum path of 248 characters. Rename the models to a smaller name to see if it fixes the issue, just so we know. Okay, so that all looks very good, and I think we should just push this because I don't think we have any builds going. Yes, we don't, and probably not going to be doing a lot of work on this project just yet anyway. Right, so we'll leave Travis to do his thing. Okay, and here we can just basically say, yeah, the job is done. Move this story to the top. For good measure, I might also, since we're wasting time on sort of easy stories, I'm also going to fix this problem because also quite a simple thing to do. I hope. So I'm just going to go very close to the profile and do something like MASD dot. Probably need a profile to give you an idea. Right, so we need two things really. Tests.CMakeLists, test.main, and tests. 3 things. So MASD.generation cdp.tests not enabled equals false, and then if we just do mass.generation.cdp.tests not main. I don't actually know if we need to, after disabling tests, if we need to. I think, well, you know what, I'm just, it doesn't make sense to me to disable individual components, so first we'll try it like this. What we'll do is we'll just remove that. Put a note here. Generated tests have been disabled for this model because there are no generated types to test. This causes the generated tests to fail once generated types have been added, or the bug is fixed. Remove this configuration. Right, just so we are aware that we've done something here. And now what we do is we just go back to Dogen. We can just go in generate tree. Oh, that's not what I meant to do. Now the fake type gets deleted. Now if you remember, we always have this problem. We keep forgetting to update the JSON model. So converts injection.json.ir. Dogen, of course, and indent the JSON. Now what we'll see as usual. Now this is rather annoying. As you can see, we have now a hunk that has half the things we want to get rid of, because it's just due to the bug that we mentioned about 10 times here, but the other half is actually the changes we made, and they're all intermixed. This is really, really annoying. There's not much we can do, so what we'll do instead is we just go into the file in here, try to manually massage this chap into some kind of sense. Right, so now just have to make sure we are not duplicating things, which of course we will be. So I assume this will be here somewhere. Dogen profiles technical space is here, and now this may not be entirely in the right order, but oh, it is. That's sheer luck. Now if I look at the diff, it looks much healthier. Now then, if we just go back to this chap and run the tests. Let's just compile first. And run the tests. Hopefully a lot of greenery will ensue. We're never quite that lucky. Now look at this. Due to the silliness of not naming things correctly, we couldn't find the test a second ago, and I was getting very upset that we were not testing that properly. As it turns out, it was just that we don't know how to name things. Where is that test? Quite sure where the test is. Code generation chain tests. Like code generation chain test. I was pretty sure we were in a code generation chain test, right? Clearly not. Ah, there we go. So, right, as you can see here, we did do a very good job here. Right, so just the problem was simply that we did not name this correctly. Well, put it this way, we named this, how should I say, quite descriptively, so that the tests are actually named very nicely. And as I said, there's a limitation of the names of the models, so that's why there's no match. But what we should do, let's just do two things here. We will keep all these names as they are, but we will of course update the names of the models. So where we say do not delete empty dirs, we just say skip empty dirs, and where we say 2 layers, we just say 2 layers. And similarly for JSON, skip and 2 layers, right? Now that's going to fix the problem not finding the test. Now, just so we don't have this problem in the future, we will just say something like the model name is, so maybe put a note here actually. Note, this test is for model. The name, the model names must be small due to Windows limitations, so that is why the test names do not match the model names. So the objective of this comment is twofold. The first thing is whenever you do a grep for the model name, you now see the comment, which is what we just did a second ago in Feld, and also whenever we get upset at the naming of the models, it explains why, so that we're not going to raise yet another story moaning about why we decided to give such a stupid name to the models. And what we can now do is we can now say create the tests. We can say, well, actually that story is cancelled, and we can put a rationale here saying test existed but name of tests did not match the model name. Okay? And this just gives us a track record, so that in the future, if we ever want to figure out what happened then, when we're grabbing for the model name, we'll see here. Now then, what we are trying to do is to run the tests. It's going to result in some compilation, and hopefully LSB, for whatever reason, decides to give us some information. Okay, cool. That is much better. So now then, we've done two things here. So what I'm going to do is I'm going to, oh, not that either. I'm going to close this story, because we finished it really. And you've noticed, it wouldn't help to notice that, okay, let's just get rid of this archive. I just archived something, a mistake. Now, what I was going to say was, you won't fail to notice that we now have two things here in this commit. Let's just commit these things separately. The first thing, interesting. We are generating. Yes, we should update the. Okay, I think we found yet another problem. Sorry, I'm just going to quickly write this down. This is the life of an open source developer. It seems like every time you're doing one thing, about 20 things happen. Add conditional logic for the inclusion of generated tests. At present, generated CMake files do not take into account generating test folder. Well, this is actually not a very good comment, but I'll get the gist of it. And if I just put this here, we'll look into that next. Right, so let's just not lose track of what we're trying to do here. What we are trying to do here is to say, we'll ignore this for a moment. Though to be fair, that should have caused the problem. The only reason why this didn't cause a problem is because we are not testing the relational model at present, which is yet another problem. So what we want to also do here is to say add relational model. Well, since we have got a story on the relational model, what we'll do instead is to say add a test. Add relational model to the Dogen model tests, and that's why that didn't break. What we are trying to do is to say the tests are broken at present. They are broken because we're pointing to a non-existent model names. So what is part of this commit that fixes this problem? Well, these two bits here, and that guy too. This is all fake test, injection model changes. This is the problem we mentioned a second ago. So this is the first commit here, which is well, 2 layers, skip empty movable folders, and renaming of models. These models have been renamed in the reference products. Update the tests to match. Okay. That's the first thing. The second thing we did was we handled the fake. We handled the fake tests. Now you'll probably say, well, you're actually not testing anything at present because you're not generated tests, so you don't know if that works or not. So you're just gonna have to trust me that this works. We will see that in a second when the nightly kicks in. So in here is injection.json, remove fake type to and disable. No, so just to say remove fake type. Instead of creating a fake type to handle a bug. So 1 second, so we seem to be having some comms from downstairs. Let me just see if I can pause the recording. Now I'm not sure if the recording is still going. Right, hopefully this did not interrupt the recording. I'm not quite sure. This is the first time I tried using the pause in OBS. In a second we'll see if that worked or not. We shall continue, soldier on. So what was I saying? Remove fake type. Instead of creating a fake type to handle the bug in tests generation, we disable generated tests altogether and removed the type. Something like that. And we probably should just commit this backlog because it's becoming a bit unwieldy. Agile, sprint, backlog, and grooming. Okay, and now then, we have to handle yet another problem. Okay, so now the problem is, let's go back to Agile. The problem is that we have manually added some logic, and so this is something that was done during my commute, so I haven't probably explained this very well. So if you take, I don't know why I_do keeps going away. Must be some kind of problem between I_do and Helm. So if you take any arbitrary project, you'll see that my CMake list now includes an if that basically says, well, if the generated tests are here, just make sure you include them, and if they're not, just don't bother. Now the reason why we need this is because when we go into full generation mode, because many CMake files have been generated manually, they will not include because they're not going to, of course, because they're not going to get regenerated because they're manual files. They're not going to be able to pick up the generated tests, right? So that's going to be a problem. Now, for the files that are automatically generated, at the moment there's only one, which is the relational model. But for those, in reality, this is not a big problem, because actually what will happen is it will include the generated tests if the facet is enabled, so these will get regenerated. So in fact, really the solution to this problem is a bit more like, let's just make sure the story captures this, and let's make sure that we are clocking the time correctly. So we stop this at 24, 25. So what we're trying to say here is that for the files that are generated, we probably just don't want to touch them, really. It was more of a mistake than anything else. What we really want to say here is don't actually add this if in a generated file. Just commit this, actually. And what we'll do is we'll just say, okay, fine, this is done. Actually, the right solution is to remove this and crafted code from generated files. The generated code will insert there, and just put this in the directory if the facet is enabled as required. So the generated code will actually do everything we need. So all we need to do is to say, stop faffing around, don't touch these manual files, those generated files, and so we'll just basically commit the change. So relational, remove, and crafted changes to CMake file. Right, so, wow, this was a lot longer than expected. We already are almost into an hour, and we haven't actually done any work yet. So let's just then look at the actual thing we're supposed to be looking at, which is we are now trying to understand if our simplistic views on the nightly would work. So what are these simplistic views? So in scripts we had that cron job of ours, and what we've done to that cron job is we so you see here we just do a checkout of the C# ref impl, we do a checkout of C++ ref impl, and interestingly we are not actually doing any git pulls from here, so I would have thought that we would get we actually get the number of changed files here. It's a bit surprising, actually. So a second ago when we went to C dash and we were looking at our nightlies, the nightly didn't show the number of files updated in a clone on the version control. Now that tends to happen sometimes if we do something outside of CMake, where we do a git pull, and then CMake, when it does a git pull, nothing happens. But clearly this is not the case here. I'm not quite sure why we never see what's changed between one nightly and the next. It's slightly puzzling. Okay, you can see that we have 42 tests less. Now, I'm not entirely sure that's a good thing. I would expect 42 less and then 42 more. Okay, something didn't quite go right with our change. In other words, because the files have changed names, you would have thought we would have seen it going up and down. So if that's not the case, then the question is, why did the test go missing? And also, which test went missing? CMake is not telling us. Oh, there we are. So do not delete empty dirs. Generated tests. That's very interesting. Clearly this should have gone missing, that's fine, but we should also see an additional 42 tests that appeared. So why do we not... Okay, so, sorry, forget a little bit about the nightly build for a second again. Let's look at the generated models. So let's take 2 layers for example. There are generated tests. There's the CMake lists. There's the included generated tests. It all looks pretty good. And if I look at skip empty dirs, similarly, there are the generated tests. And everything looks very good. So why does CMake think we dropped 42 tests rather than renamed 42 tests? Let's keep looking here, see if we can find any reference of 2 layers. Lot of tests here, but the models are quite large. I'm just going to start from the end. Student model. This is one slight problem here, is that there's just so much stuff, we're not going to be able to see anything here. The best thing to do is probably to just go not to C dash but to the project itself. And then if we jump over to Travis, she's still failing. Now it's worse than that, it's failing to even start the build. We're just going to leave that OSX build alone. At some point it will sort itself out. Now in the ref impl, presumably in any of these, so let's just take Linux. I think we're not going to do very much in this session, to be honest. We're just going to be addressing these issues and then it's going to be time to call it a day. But I'll do another session today. So if I just say 2 layers, Chrome finding 2 layers. Okay, we seem to have not compiled 2 layers. Clearly, it's being included here. Just for a laugh, let's just look at the raw log. Sometimes there is no mention of 2 layers here. That's very strange. Are we actually in the right build? Well, let's just look at this commit, because we must have done something silly. Ah, most interesting. Most interesting. Would seem, according to that. Ah, okay, right. So it seems like we forgot. Okay, that's fine. We just made a silly mistake. We forgot to commit. Add to the layers. Skip into your folders to project. Okay, that's fine. It's good that CMake told us that, because otherwise we would be missing these tests and not knowing what was going on. Right, so we will just do that, and then, well, Travis is very quick, so it's done it already. Windows takes a bit longer, so it will just automatically cancel the ongoing builds. I'll just have a quick look at Windows. Yeah, we'll just cancel this build, because there's no point in waiting for this build. And now it will build properly. Okay, cool. It was very good that CMake told us that, really, because C dash, should I say? Because otherwise we'll be not knowing what happened. What I'll do is I'll clock this time as part of the work to address the problem, to give it a more accurate picture. In fact, I don't think we are clocking at present, so let's look at the last thing we clocked. 11:32 is 11:41, and just put something here for this work. Righty, now then, where are we? We are looking at this nightly business. Still attempting to split. Well, what we'll try to do for this exercise before we break for lunch is to try to just run the script and see if you can upload experimental. So going back to what I was saying, so this is the nightly build script. It obtains the C# reference implementation, obtains the C++ reference implementation. Now of course we need to compile and run all tests and so on. We need to do the nightly for the reference implementation, so that's fine. What we'll do though is we will comment out for now this work, because we don't particularly care about these guys. We know that works. We just want to make sure that we have these guys here. Then we enter Dogen. So now observe what I did in terms of changes. First thing we do is we get rid of the Git directory for Dogen, if it exists. And we also delete this pristine dir, which we'll see that in a second what that is. Finally, we clone Dogen. I want to go for the depth of 3. Because the thing is, with this clone here, it only happens really once. This clone is going to happen every day, so it makes no sense to clone the whole repo. We go into the Git direct. Of course, we make a copy of clone of the thing we just cloned. Now you'll notice that we should have copied it to the pristine dir, and then we set the projects directory to be the pristine dir. So of course now you understand why it's called pristine, is because we don't want to touch this guy. We want to make sure this is as it is in master. Then we enter the non-pristine dir, which is called git dir here. We do a build of the CLI. We enable full generation. We generate all diagrams, and then we take over the usual nightly of Dogen. So if all goes according to plan, this should be very reproducible, because we are trashing everything from scratch every night. So the other thing I'd like to do as well is I don't want to call these guys nightlies, because we're going to have to run this about 3 or 4 times until we get it right. So let's call these build group. So there's an option here which is the build group, and we set the build group here. So if I go back to the script and look for build group, you'll see, here we are. I'm just going to call this experimental. Right, now then, well, let's experiment with the experimental. So in the nightly builds, we have a directory called scripts. Now, I will actually make a copy of this script. You probably laugh that I'm not making a symlink. It's because I quite like the fact that is sort of reproducible. So I know what script I took when. For good measure, what we probably should do as well is we should probably put a commit hash on the script as well. So that will tell us exactly what commit it was that we're using. Because it's going to become increasingly difficult to know what script we're using for your nightlies, right? So first we'll just test it and then I'll rename it. Now then, if I just run cron sure, let's just see what happens. Okay, seems to have done the job there. Now just maximize this for a second. Let's just look at what this shell script is saying. So we're cloning. Well, whilst the build is taking place, let's make sure that the pristine directory got created, which it did. Both of them seem to be fairly new. Okie dokie. Now then. Whilst this is going on, one thing I'd like to also mention is, if you remember, we found that bug where code generation, well, not code generation, code coverage was not being updated. This is also quite a worrying thing, and we also should really set up code coverage from the nightly, as I said before, because we want these two kinds of code generation. However, I won't be able to film any of that work, because I think the problem is we probably have API keys somewhere and there's some encryption and stuff like that, and I'm not entirely sure if it's a good idea to be showing those things on YouTube. So what I'll do is I'll try to do that work on a separate session. Probably I need to be connected, so I can't do it on a train, but I won't be recording those sessions. It should probably not take that long. Then I'll explain what I did at the end, just in case I start publishing my private API keys by mistake on YouTube. We're doing for time. One hour recording. Okay, so what's happening at the moment is our nightly, our experimental, is doing what we wanted to do, which is to build CLI. It takes its time because there's so many, most of the master branch is composed of things that are required for the CLI. Dogen, not much you can do. What I tend to do in these sort of downtimes is I tend to have a quick look at the backlog while I wait, just to see what's going on. So as you can see here, there's the removal of test model sanitizer, which we did quite a while ago. What we want to do is see if there's anything obvious here that can be done in 5 minutes while we wait for build. I have sent an update to Alexander Miller, so let's have a quick look at the Tremax Jira, see if Alexander replied. Without problems with the org, apparently can't reproduce those problems. We sent a stack trace, no mention, so leave that as is. We also had the Windows builds going. They take a while, sadly. Here we go, so 42 tests are back, so that seems to have done the trick. Okay, so at this point in time, our builds are in a good state. This is as good as they're going to get as part of this work, and they're going to be mildly green. They're not quite green, as you can see. We still have errors all over the place, but these are known errors that we just need to sit down and try to figure out. Oh, most interesting. Our experimental has concluded a bit quicker than expected. That was rather unexpected. Not entirely sure. Let's just log in. I think there's a problem with this reference. I think the problem with that is that this revision doesn't exist. Not clear. What's this? Okay, there is a bug. The bug is we seem not to have generated tests. Right. Now then. This is most interesting. Okay, cool. Fortunately, so let me just explain the problem. The problem is this. Everything is working as we wanted. The overrides generated tests. But if you remember, we always had that problem where, for some random reason, enabling tests was not sufficient to enable things on the tests. So if I show you the profile, we separately needed to enable CMake lists. Yes. So test all facets should have had a number of things here set to true. Interestingly, they set to false. Okay, let's just first, one thing is always good to do with Dogen, you probably will, like me, learn this the hard way, but every so often make sure you close all your diagrams, especially when you're working with 3 or 4 machines. Because remember, Dia does not automatically reload diagrams, and it is very easy to start losing state because you've opened diagrams in the laptop, you've changed something, you pushed, and you forgot to reopen it on the main PC, and then everything gets really messy. So to make sure you're working from latest, every time you start a session, it's good to just open the diagrams. I mean, it would be better to just fix Dia, of course, to reload, but here we are. Now then, in here, we seem to have done the very strange mistake of setting CMake lists and main to false. Now I have no idea why we did that. It should have been true. And there we are. That's probably a very good explanation of why this is failing. So what we'll do now is we will... Sadly, I think we need to push at this point in time because otherwise probably going to cause problems. So what do we do to this model? A lot of changes here. I'm just going to take this as cosmetic changes. So let's just say models, enable main and CMake lists in generating tests profile, and then cosmetic changes to generation.cv model. Now that is something on its own. And in here, well, since we're going to commit, it's probably wise to just say let's update the backlog. In fact, to be honest, you know, sometimes I like, if this is all connected, it makes sense to just commit everything together. Now then, let's try pushing this, because of course you remember cloning from GitHub, so there's no other option. We have to push. And what we'll do is we just run our script again. Remember, of course, there's a annoying penalty of having to wait for the build and so forth, but there's not much else we can do. Good thing about this, of course, is that we now have we can see the builds from here, so let's just remove this build. We don't really need it. Okay, so well, we just have to wait. Again, since we're waiting, let's see if there's anything we can get cracking with. We have to maximize our usage of time. Oh, interestingly, we're not using Clang 9 and GZZ 9 nightly. Perhaps this is something we could look into right now. Let's just say... what time do we stop clocking? 53. Don't like dropping minutes, to be honest. Not if we're actually doing work. So in the nightly... Ah, interesting. We've already started tackling this problem, because as you can see, the Clang compiler is 9. So, sadly I deleted the build a second ago. It would have been nice to make sure the Clang compiler is coming through. So this is already done, so let's not worry about that. We'll just mark that as started. But I don't think we can claim any clocking time here. Consider creating a test build for all facets. Right, now then, how does that differ from the work we're doing right now? So split. Okay, we seem to have a clocking error here. We should be clocking against this story. Consider creating a test build for all facets. So we have a split generated test or manual test. So then I think, to be fair, what we probably should do is to say, actually, we've done that. I mean, we have split the generated test and manual test, so I think this is done. And really, we are considering the creation of a test pool for all facets. That's what we're doing, really. It's good not to mix and match all these things. Now, we have to keep an eye on that build. Approaching 900. So that's good. And yeah, we should probably say to this one, the current workaround is to disable generated tests whilst there are no types to test. This is not ideal because if we introduce testable types, we will probably forget to remove disabling, but it's better than adding a fake type, arguably. Don't think it's a very straightforward argument. That's good. Let's again have a quick look at what our chap's doing. Banged again. Why? Most interesting. Okay, let's have a look. This looks slightly more promising. Relational is the problem. Okay. Ah. Right. Notice that we have got CMake enabled set to false. Not sure why we do that actually. It's very puzzling. I mean, of course, most of the time we don't really use CMake for this sort of stuff, generation, but that's not a good idea, I don't think. And of course, every time this happens, we then have to wait forever. What we'll do is, just so that we don't have to wait so long, let's just do a quick hack. Let's just update the profile of this checked out code. Now I'm just gonna do a very quick hack here because otherwise we're gonna have to wait another God knows how long. We're just trying to see if this thing actually does anything sensible. So I'm just gonna look at this profile. Let's see, make lists false. Okay, this looks like it. Let's just set that to true. Right, now of course this is not a very good idea if we don't really remember what we're doing, so and we need to also have a quick look at the script. Now this is really where things start getting a bit icky because, you know, I'm going to start modifying this script, which is not in Git, but there you are. What we want to do now is to say, well, we already know that these bits here work. We just want you to export. Don't bother build the ALI because we know that's good. And run the nightly. Right, so now it's going to be a little bit quicker. Okay, it's actually even quicker than I expected. We probably can't have ifs if there's nothing to do in the if. Now, up to now we haven't done any change that requires changing the Git file, the file in Git. Okay, that's interesting. We would have expected Okay, so now we got us knickers in a bit of a tangle now. Right, this basically, in order to salvage the situation here, we need to do another hack. The problem is CMake is expecting this project to now have a CMake file. It doesn't, and because of that, it can't continue, so it can't regenerate the project, so we can't get ourselves out of the tangle. So let's just say we ignore that project for a second, regenerate everything. We don't particularly care if you just exclude that project for a second. Now bear in mind that we haven't done anything to the script itself that needs to be committed back to Git. Now this is now apparently doing something. I wanted to see something here, and yes, you see that there's some GCC 9 stuff here. Okay, so this is the upgrade to GCC succeeded, so let's close that story. Start removing some of these builds. We have a limit how many builds we can have, so... Okay, that is actually looking quite healthy. So what I'll do... Oh, bang. I shouldn't have said that. Now then, oh. Login configuration, namespace utility log does not name a type. Most interesting. That's actually rather interesting. Implies that we are doing something different. I mean, it's not even failing generated tests. It's actually failing in a regular Dogen thing. Okay, so what we'll do is, this is very puzzling. What we'll do is we will do yet again another hack. First thing before anything else is let's go to Dogen. Now remember we're inside of the nightly. It's very important we don't lose track of what we're doing here. So as you can see, there's a lot of generated code here and a lot of modified code. In here we will find that relational. We still don't seem to be generating files for relational. That's very puzzling. And not just that, but so let's just put this back because I want to see those errors. Now let's make sure our includes are correct. So this seems to imply we're not including log configuration. So if I look at this includes, I mean I can't even begin to think why we're not including log configuration. Should be here on the size. So if we just take this guy here. Ah, interesting. We have found a problem. Actually, the generated code is not compiling. So this file forwards it. So this is very good. So we've already found the problem with the generated code. So this is a forward declaration of the serialization header, and it seems to be using a type, but it's forgot to include that type. So we seem to have been generating. So the first thing we'll do is we'll just have a look at what exactly is this logging configuration. This is exactly what we wanted. We're now finding errors in files that we normally don't generate, and that's why we want to generate everything. So if I open up utility, which is a bit of a special model really, there's the logging configuration, which is fluent, and now we're serializing it. So if we have a look at utility, include, see all the facets are coming through here. We want serialization, and then log, and then forwards. Now then, yes, we are somehow we seem to be forgetting to include the type in serialization. This is a very strange bug because, well, the first thing to do, of course, in this kind of situations is to look at the reference model. So let's just jump over to the reference model. Just choose a type because we are generating everything for the rest of the reference model. So let's use a type in our C++ model and look at their serialization. So for example, A class serialization. Now you see here, this is correct. This is what you'd expect. We are including all the serialization headers as you'd expect. So what is so special about login configuration? It seems like a regular type. Interestingly enough, it's fluent. Not sure if that makes any difference, but doesn't look particularly special in any way. So why would our code generator not be generating the includes for it? This is going to be a tricky problem to debug, I think. Let's think about this for a second. Well, first thing to do probably is just to say, can we make it not fluent and see if there's some weird bug. Now, I just want to make sure we are keeping an eye on where we are. Because remember, we're inside of the nightly build, not inside of our build. Perhaps that's what we should do first, really. We should try to compile from our build, not from the night. Yeah, exactly. Let's just do that. So, okay, change the tact here. Because we are now doing a lot of changes, this is no longer a problem with the script, right? The script has done this job. None of the problems we found up to now are with the script. The script in the nightly now is completely out of sync with the script in Git. And we are now starting to do some coding from within the nightly directory. Now this can't be a good idea. So what we'll do instead is just to try to reproduce the problem in our Dogen area. We'll just return to the shell. I mean, this is no longer a nightly problem, right? So let's leave the nightly alone. Let's go back to Dogen. And in Dogen, what we want to do is we want to reproduce the scenario that we're doing in the build. In other words, let's just do full generation. Now we have to make sure our profile looks good. Everything is fine here. So we will first we will save the change we made. Models, generate to make files for test profile, which is good. The second thing we want to do is we want to make sure. To be fair, I'm actually going to leave this with experimental for now because we'll remember to update that. So let's just say scripts fixes to nightly build. Oops, I mean, name cron is obviously not a very good name. Not really sure why. Oh, we must have moved things around here. So when that happens, I like committing because I don't really want lots and lots of changes in this file, and then it becomes really difficult if we make a mistake and lose some stuff. Also, the other thing I wanted to do is to say, as far as I'm concerned, we have upgraded to GCC 9, Clang 9, because they all come through as soon as this script is plugged in. So let's just call this agile backlog grooming. Right, now I have a clean slate to start from. So what we'll do now is, this. Let's just also kill the scripts, and let's make sure the script we have doesn't have anything commented on. It does. Right, so we have to be careful with this script. Well, we'll just leave it like that for the moment, that's fine. Now, what we're going to do is this. We want to go to the make file, main one, and say with full generation is on. Notice that no, that's correct, it's all models. So what we're going to do is let's just look for full generation and set it to on. Let's put a large fix me do not check in, so we remember. Then what we're going to do is we're going to simply generate everything, and then we're going to have a quick look at what that looks like. Not a lot. Okay, that was surprising. Expected a bit more drama. Rather underwhelming. Really expected a bit more drama. Yeah, okay, as you can see, CMake is being very clever for us and doing some kind of crazy caching. Not to worry, we will convince it not to cache. Let's go to our build, output, line 9, release, and the cached variables leave around here somewhere. For just set this to on. But hopefully that will be a little bit more. But that looks slightly more exciting. Now, you can see a lot of things here. First thing I'm going to do, even before I do anything else, is did it relate the relational? Does it look alright? Well, to be honest, the best thing to do is probably to just hop over to the code. So if we go to, say, making sure people are not talking to me. Nope. So if you have a look at the relational model, yeah, see, this looks a bit better. We still have our mark. Okay, cool. So then, now we've got that. What happens if we attempt to build? Okay. Login configuration is blank. Okay, good. So we reproduce the problem in a much nicer scenario on our crazy 90 build. Like, oh, let's make sure we snap to grid. I quite like a little bit more space in my models. So now then, well, the first thing we're going to do is, before we do anything else, I know it's a bit silly, but let's see if the fluent, I'm sure we're not using fluency for anything here. Let's see if there's a bug in the way fluent has been implemented. And if so, we will just have a look at that bug. No, it's not to do with fluency. Same problem. Okay, cool, we'll just put that back then. Okay, if it's not a problem with fluency, now we have to understand why it is that login configuration does not think it's a good idea to include the headers for its type, given that everybody else seems to be doing that. This is exactly why we need a relational model, because now we've just been doing a couple of queries in the database. This is the typical paradoxes of Dogen development. Hopefully we'll not have too many of these bugs. What we can do is we can generate utilities separately. So what we'll do now is we will start enabling our tools. Let's get log to the maximum, and then let's just do a generate Dogen.utility. Now that went away and generated the model. We're in compilation, so let's not lose where we are. Now let's look at our logs. Sorry, I'm still quite sneezes. Hopefully this cold will go away at some point. So then, we have just generated what's interesting, none of these things seem to have been updated. Generated utility, expected the timestamp of the logs to go. Oh, it is. Okay, good. Okay, so we're looking for a logging configuration. But of course, this is a bit of a needle in a haystack, and that's why we need a relational model, because as you can see, we're going to have a lot of logging configuration across the... let's not do that. As you can see, we're going to have lots of mentions of the word logging configuration here. All over the place. In fact, we'll probably... let's try it with a... So, if we think from first principles, what's happening here is basically that Dogen thinks that the types facet is disabled, because if we look back into what okay, we just need to find something silly here. If we look back at where we were a second ago and where we looked at one of these, now what triggers these includes here is those facets need to be enabled. We seem to have enabled serialization. Somehow it thinks that facets associated with types is not enabled. Now clearly that can't be right, because if I go to utility and if I look at include and types and then log, clearly it's generating log configuration. And it's generated today because we've of course changed the fluent settings, so it's clearly generating this. So types has to be enabled, and it's not deleting it. So if it was disabled, it would delete it. So there is no excuse for Dogen not to generate this on the basis that the types facet is not enabled. So then we're going back to our logs. Running out of time slightly for this session. So this is just generating the facet path, primary directive. Okay, interesting. So inserting inclusion directory group. Right, this thing here is computing the inclusion directives. That's fine. What we want is inclusion dependencies. Ah, interesting. Now, as you can see here, finish creating inclusion dependencies for the analytic logging configuration, and the forward serialization is a dependency of the type. So we seem to actually have some kind of recursive. Okay, this we seem to have two problems here. So let's just go back to test model. So as you can see here, we are including the type itself in the serialization. Now that sounds a bit strange, because I assume, so that was class A. If I go to types and look at class A, and as you can see here, class A, oh wow, this is not good at all. So the type includes forward serialization, and forward serialization includes the type. Now, of course you may say, okay, well, the reason why that works is purely because C++ is clever enough with include headers, and once you've included it once, we'll just do it the one time and skip the cycle, perhaps. But it still seems a bit silly that this guy here is including this guy here, and this guy here is including this guy here. It would be better for this guy to be including the for declaration. So that looks a bit strange. I'm not entirely sure why that works, but well, it is working in the reference model. So why are we to complain? So that's the first point of note. Now, what we need to do is to find the inclusion dependencies for serialization. And to do that, what we'll do is we'll just revert to the old trusted graph. Well, to be honest, let's just keep going, because in truth we found that very quickly, so we just want the inclusion dependencies for this chap, and as you see, we seem to have skipped it altogether. Right, so that seems like there's something not quite right in the way we calculate inclusion. So let's just grab and try to see what is the inclusion expander doing. Let's just have a look. And there's only one entry here. So we seem to have skipped inclusion dependencies for the 4 declarations. Now that doesn't seem like a good thing to do, because we still have to calculate inclusion dependencies. Now I wonder if, when we created our profile, did we do something silly here? In other words, are we enabling something that doesn't make any sense? Why would the inclusion change on the back of using this different profile? You would have thought that 4 declarations will be treated exactly the same way by the inclusion expander, but it doesn't seem to be the case. Let's just make sure that we, just a sanity check here. Let's just make sure that we're not doing anything stupid when we override the profile. Quite literally, all we're doing is, we're just setting test all facets, right? Test all facets is this chap here, and that's actually just disabling C#, which is a good thing. Is there anything that we do somewhere else that we should be doing as well? CMake enable false, so enable false, hash enable false, serialization enable false, test CMake list false, test main, lexical cast, tests, test data, templates, best build, Visual Studio, C#, default profile. So there's nothing here that we probably missed or that could be causing an explanation for this strange behavior. Most peculiar. Right, okay, this is going to be probably a long debug session now, I think, so since we already are well into this video, let's just recap what we've done today then, well, in this session anyway. So we managed to get our nightly to perform the overrides and generate all the code for all models. However, once we start doing that, the code generator is behaving a little bit strangely. And that is to say, we seem to be generating invalid code. Now, we have a reference model that generates everything, and that proves that the code should be correct. However, when we use the code via these profile overrides, we then start to see behavior that's different from the reference model. So clearly there's a difference between the two approaches. We just don't know quite what. In fact, that gives me an idea. Let's just, before we go any further, let's just do something really, really simple, and then after that we conclude the video. We'll just disable again the generation. In fact, I'll just go straight to the cache, to be honest. Right, so what we'll do is we'll disable generation, we'll generate all models. Start writing to the cache randomly. And then if I go to git, what you see is not a lot. Interesting, we didn't bother to delete the generated tests. Interestingly, we're still using the profile to generate tests. Now that is not good. Let's just for good measure also set it to off here. Not entirely sure why we didn't revert back to a good state. Interesting. Now, this is another bug we seem to have found. So what happened here is Dogen, for whatever reason, did not decide to delete the generated tests, because it's still generating CMake lists. Not sure why that would be. Why is this Dogen still generating CMake lists? and still using the profile, the incorrect profile. Well, this is where unfortunately we get into a bit of a state. So unfortunately, in order for us to continue, I'm just gonna have to manually delete all of these. The reason why I need to do that manually is because we are doing something silly somewhere in Dogen. Now, hopefully, if I run GAD again, right, so what's happening here, of course, is for every generated file, which to be fair, there shouldn't be many, seem to have overridden manually. Oh yes, I see. Okay, so what's happened here is we seem to be, because we must have enabled CMake generation. Right, so we have to be careful here. So there is some. Oh, okay, right. This definitely is not a good thing. So you see when we say CMake enable true, this is a problem. This is a very big problem. So we can't say that. We must say that CMake enable false. The reason why is because we only have one project that requires CMake, and that's relational. And then what's happening now is we are now starting to create a big confusion here. Let's have a quick look at what Relational is doing. I mean, it's fine for it to require CMake. So it's using the relational profile. Let's have a look at the relational profile. CMake enable is true. Okay, so that's fine. Let's make sure we set CMake enable to false here. This is our problem now. Okay, so we have a problem with the relational model because we are overriding every single model, including relational. Now you see we have a special configuration for relational. We are setting CMake enable to true, we're setting CMake list enable to true, and the tests, ODB enable to true, and main enable to true. Now, in this particular case, we're not going to be doing this, but on the plus side, we are enabling every facet. So that is probably fine for all cases, with the exception of one, and that's CMake. We are generating CMake for relational, just for relational, but we are not generating CMake for every other project. So by saying set CMake to true, we've overwritten all the manually crafted files. And that's why you're seeing all this stuff. And now we're in a bit of a state. There's nothing else to do but to just get rid of all these changes. But that's definitely going to be a problem. But we'll just have to confuse one issue at a time, really. Right, so the problem there is that there's CMake cannot, relational cannot be overridden because he's got some special settings, particularly one setting. What we need to do really is to say relational CMake enable false, and by doing that, and in all other cases CMake enable false. Now we will just take a snapshot of whatever CMake we've got in relational at present, and that will then be our manually generated CMake files, and that's fine for now. So what I'll do now is just to double check that this is all kind of making sense. Let's just do another generate all with the new profiles, and in here what we expect to see is it attempts to delete. That's cool. It attempts to delete the CMake files. So we just have to go to relational and teach relational without ignoring CMake files. It's just a question of adding this regex. Which is identical to the other regex here. Now I know this is not ideal. There's a lot of confusion. Probably are not quite understanding everything I'm doing at the moment, but that's unfortunately right. So we just had the regex here to ignore CMake list.txt. Looks similar to the other ones, and then again we will go to relational and say, let's just make sure we put this in somewhere safe in our staging area. Now we're going to regenerate yet again, and now we're going to see is that there's not going to be any differences in Git, which is what you expect. So to recap, relational model was generating its own CMake files, which is fine, but it's actually the only model doing that. When we do the profile overrides, we then set generate CMake files to either true or to false. If we set it to true, we override every single manually generated CMake file. That then causes its own problems. If we set it to false, we don't generate CMake files for relational, which means that we can't build relational. So that's also a problem. So now what we're going to do is we're just going to, before anything else, we're just going to convert these two profiles, these two models, into JSON. And relational, of course. Now we should have a JSON representation that yet again we have the problem we just mentioned a second ago. This time what I'll do is just gonna take the model as it is, dump everything, and then why do we only have tests? Are we actually in relational? We are. For some reason we don't seem to be ignoring ODB. So the order is first ODB, then test, then let's just make sure we are ignoring this exactly as we are in as you can see here. Oh, just be careful. In fact, let me just copy this. Regex. Clearly the only reason why this is not causing us problems is because we're not running any tests against the relational model. Right, so there you are. This should look similar. ODB tests, CMake lists. Good, so that looks better. Profiles hopefully will look better too. Okay, cool. Now, at this point in time, where are we then? We have probably gone back to a decent build now. It's going to take us time to do the build, so we'll leave that for its to do its thing. And then what we're going to do is, for good measure, we are just going to try to manually set the profile to the override profile and see if that makes any difference. But this time, instead of having 100,000 files changed, we shall only tackle the breaking model, and that was we deleted everything here. Well, we don't have to go very far. Utility, so we just have to update utility. So okay, cool. That sounds like we have a plan here now to debug this problem. It's also a very good demonstration of the kind of problems you face in Dogen when you're doing hardcore things, which is what we really want in this series of videos. So update profiles and relational model. Do not generate CMake files for relational, as this causes problems when used with when overriding the profile with what is the profile name? Test all facets. And similarly, what we did was we look at the diff in profiles. A lot of noise, but really what did we change in profiles? sometimes this is where JSON is quite helpful, because in JSON you can clearly see the diff, there's no noise. So we disable CMake. Sadly there was more things that we haven't actually updated the JSON profile in a while, it seems. Well, let's just go back to our commit. I think that's the gist of it. So do not generate CMake files for test all facets as it overrides the manually generated CMake files. That's probably enough. Right then. Don't think we can progress much further now, so we're just going to break now. Where we are right now is we need to understand why it is that the utility model fails once we move over to this profile, test all facets. It seems that the inclusion of 4 declarations is no longer correct. We should probably also write a note in our backlog, which by the way I forgot to update with clocking. Should say something like serialization forward declarations are recursive. At present we are including the serialization forward declaration from the types header and also including types header from the serialization for cyclical. Relation. We should probably include the types for declaration. That'll be slightly more sensible. Right now, and then whilst we are working on this, we should probably clock all this time as well. Could just say this was backlog grooming really. Now we don't want to commit this because there's just a lot of hackery going on. So we'll just say agile sprint backlog grooming. Right, so that, well, since you're here, might as well push before I go. Okay, so in conclusion for this session, we made some progress in our nightly. We are now able to generate all the files in the nightly, but unexpectedly when we do that, there's breakage. This is very unexpected because we are generating all facets in the reference test model, so we'd expect the same thing to happen, but seems like there's some kind of difference between profile overrides and actual profiles somehow. That needs to be investigated. So thanks for watching. We'll continue in the next episode with that investigation.